A tangent to any curve is the line which touches the curve and has the same gradient that the curve does at that point of contact. One interesting case is when we have a tangent to a circle. This tangent is always perpendicular to the line which connects the point of contact and the centre of the circle. One way to visually see this is placing the circle inside a square of minimum size and drawing lines to connect the points of contact between the square and the circle. The symmetry of the circle means that these lines all pass through the centre of the circle and that all the angles are right angles. This property of the tangent to the circle gives us a way to figure out things about it. Let's put the circle of radius 5 with its centre at the origin of the graph and add on a tangent to the circle at point 3, 4. This tangent is a straight line, and to know everything possible about the line, we only need to know two things about it. This could be 2 points that the line goes through, or it could be 1 point that the line goes through, as well as the gradient of the line. With 2 bits of information, we can find the equation of the tangent and answer any question about it. We already know one thing about this tangent, that it goes through the point 3, 4. To obtain the other bit of information, we are going to exploit the fact that since we are dealing with the tangent to the circle, this line going from the centre to 3, 4 must be perpendicular to that tangent. Remember, if two lines are perpendicular to each other, it means that their gradients are negative reciprocals to each other. The gradient of this line from the origin to 3, 4 can be found since we know 2 points that it goes through, the origin and 3, 4. The gradient can be found by the change in y over the change in x, which is 4 over 3. Therefore, the gradient of the tangent must be negative 3 over 4. We now know 2 things about this tangent, so we can find its equation. To do this, we write the general form of a straight line, y equals mx plus c, and replace the m with the gradient, negative 3 over 4. Now we sub in the point 3, 4 and rearrange to find out what c must be. Now we have the equation of the tangent. Of course, this method will work regardless of the radius of the circle or the point of contact of the tangent.